Hi everyone, and welcome to this new iTrain tutorial. iTrain stands for Interactive Training in Reduction and Analysis of Interferometric Data, and is a series of live tutorials organized by the European Arc Network. You can find all previous tutorials online in this YouTube channel of the European Arc Network. Today, we have the pleasure to welcome Wang Kuosong, who will show us how to make the best use of CARTA. CARTA is a tool for image visualization and analysis designed for ALMA, VLA, and SK pathfinders. So Kuosong is working as an ALMA support scientist at the Academia Sinica Institute of Astronomy and Astrophysics in Taipei, in Taiwan. He has been involved in the development of CARTA as the project scientist in the past few years, and is working closely with developers and astronomers on feature design and implementation. We will start first with an introduction and demos on CARTA, and then we will stop this recording and we will continue with a session on question and answers. So now, with this word, I leave the floor to Kuosong.
Okay, and so we will be talking about a few topics today. This is the outline. So I will firstly introduce a bit more about CARTA, and followed by 4 tutorials, including how we can load image into CARTA in different ways, how we render images, and how we match images, and how to use the built-in tools to analyze your spectral light cubes. And if you have catalogs, then you will learn how to load catalogs into CARTA and visualize it. And the last one will be showing you how to customize the entire graphical user interface. And we will make a short conclusion at the end. So basically, after this tutorial, I hope you will learn how to do these things, such as the screenshot on the left, on the right side. Okay, so before we start, I would like to use this chance to, as a project scientist of this CARTA development project, and also as a user, I would like to thank all our developers in our team to make CARTA real. They play a very important roles in this development. Without them, CARTA cannot happen. And also, I would like to thank you for considering use CARTA for your research, and we hope CARTA can make your life easier. Okay, and let's start the first part, the overview of CARTA. So regarding the CARTA development team, we have 4 institutes involved in this CARTA development. I'm in HIA in Taiwan. And also we have developers and people from IDIA, from South Africa and Cape Town. And we have developers from NRAO in the United States, and also developers from Canada, Department of Physics, University of Alberta at Edmond. The team scale is about 20 people, around 20 people, including development team, science team, and also the management teams at the moment. Regarding the CARTA releases, so on March 2018, we have the so-called project reboot. And after a few months effort, we released the first version, version 1.0 in December 2018. And after that, and counting the releases, we have 12 releases since 2018. This includes the official releases, patch releases, and also the beta releases. The latest official release is version 2.0, and also the latest beta release is version 3.0 beta 2. In this tutorial, I will be using this version 3 beta 2 as a reference version for demo the features. We target to have 1 or 2 official releases per year, and also a few beta releases between the official releases, so that you can try the latest features or new features from these beta releases. Just let you know that the upcoming one will be the version 3 final release, and it will happen around the summer this year, 2022. So to obtain CARTA, please visit our homepage, cartaviz.org to get a copy of CARTA. There are some instructions there. In CARTA, we adapt the so-called client-server architecture, which means there will be a part called the server side and another part called the client side. So you will put your big data on the server side, which can be an enterprise class server with a high performance storage system. And on the server side, we'll just get the data stream to the client side, and we will use a so-called client side GPU accelerated rendering to show your data. And the data stream is is not just sending every information from the server side to the client side. We actually apply some approximation or special tricks so that the data stream to the client side will just have sufficient accuracy for visualization. Okay, and at the client side, you will just use your browser to connect to the remote server. And we officially support, if you use Mac, then it's Safari. And we also support Google Chrome and also Firefox. And you can visit our homepage to learn more about the adapted libraries in CARTA. And you can also check our code base, as it's an open source project on GitHub. And if you want to deploy CARTA as a server to serve many people, and please visit this document hosted on the RealDoc service CARTA controller for server deployment. Regarding the deployment mode of CARTA, there are two major parts. The first part, we call it a user deployment mode. This is ideal for a single user with a local computer or a remote server. We support the operating systems, including Red Hat 7 and 8, Ubuntu 18.04, 20.04, and upcoming one will be 20.04, and we will no longer support 18.04. And for Mac OS, we support Catalina, Big Sur, and Monterey. At the moment, we still support Catalina. That's because the Apple is advertising their in-house made processor, the ARM-based processor. So that's why we support 3 versions of Mac OS. And here, just a common use case that I believe you will use often. That is, you put your data on a remote server, like a enterprise server in your institute, and you just access to that remote server. Then once CARTA is installed using the user deployment modes, then you can just open a terminal and type CARTA with this flag called --no browser. And this is important because if you don't add this flag, then a browser will be automatically launched at the remote server. So possibly that browser will be displayed through the X11 tunneling. So it's not an efficient way. So what you need to do is open your terminal, type CARTA with this flag. Then from the terminal, you should see an URL, something like this one. Then the next step would be just copy and paste this URL to your local browser, which means the computer you used to access to the remote server. And here is an important note that we do not recommend users to use CARTA via VNC, as the GPU accelerated techniques may not work, or so that images may not be displayed properly or efficiently. If you work in the big institute, and in that case, we suggest you to consider the site deployment mode. So basically, this is ideal for institute-wide deployment to support multiple users with a shared file system. And also, please note that there will be upcoming site deployment mode only collaborative tools, so that you should consider the advantage of this, in the near future. And support operating systems include the Red Hat 7 and 8, and also the Ubuntu 18.04, 20.04, and upcoming one is 2004. And once the this version of CARTA is deployed in your institute, what you need to do to use CARTA is just visit the URL provided by your system administrator. Then you just check in that URL and you should be seeing something like this one, the login page. And what you need to do is just log in with your credential and CARTA should launch immediately. And you can also use the dashboard to control the sessions or logout, etc. So please consider this deployment mode, and please also check the controller user menu to see how to deploy CARTA in this way. If you encounter problems, please contact support@carta.freshdesk.com for help. We'll be very happy to help you to deploy CARTA in this way. The next would be just let you know some techniques we use in CARTA so that it's an efficient tool for image visualization. So when we load a image cube into CARTA, we actually generate a image pyramid per channel. This means if you have an image that is, in this example, around 2000 by 2000 pixels, CARTA will actually generate a set of downsampled images like a pyramid. For example, the top one will be just one 256 by 256 image. Equivalently, the downsample factor is 8. And the next layer will be 4 tiles with a downsample factor of 4. And the next one will be 16 tiles with downsample factor of 2, and so on. So the bottom one will be 64 tiles with no downsampling factor. And CARTA knows the screen resolution you are using to view your image, so that CARTA will just load a proper downsampled tiles for you for image visualization. For example, you are interested in the blue part of this image, and CARTA probably will just send you these 9 tiles for you for visualization. And if you just pan your view from blue part to the green part, then what CARTA needs to do is to just send the additional 2 tiles to the client side for rendering. So it's efficient in terms of the data stream, and also just it's not providing a full resolution for you because you probably don't have that screen resolution to view your image. For example, if you would only have like 1000 by 1000 pixel on screen to view an image, and you load a 10,000 by 10,000 image into CARTA, there's no point, or you cannot learn much more from if you just display the entire 10,000 by 10,000 image within that small screen. And in CARTA, we adopt so-called GPU accelerated rendering, and it's actually WebGL or WebGL2 in your browser. And these techniques applies to the raster image rendering, contour image rendering, catalog overlay rendering, and also upcoming one will be the vector field image rendering. Regarding the server-side memory usage when we load an image, if you just launch a CARTA session, then the base RAM usage will be less than 10 megabytes. And if you want to say load an image that is 16,000 by 16,000 pixel, the server will just require around 1 gigabyte of RAM to do such a big image. If you have an even bigger one, like 32,000 by 32,000 pixel, then the server will just require 4 gigabyte of RAM to load the image. However, if you convert your face image into a special image format that CARTA support, is so-called HDF5 under the IDIS schema, then the RAM usage to load such big image is much less. Okay, And here, just a video clip to show you that, for example, CARTA can easily load an image queue, a terabyte size image queue, 8,000 by 8,000 by around 5,000 channel. So just within few seconds, the image can be loaded into CARTA, and you can easily pan and zoom your image. Okay, and this is just this is with an older version of CARTA. So as I mentioned, that CARTA supports a special image format called HDF5 under the IDI schema. We have a tool, a command line tool called fits to IDIA to convert a fits image into the HDF5 image. And actually, this HDF5 file contains your original image cube. If it's a 41, or say the spatial, spectral, and stocks for polarization, then there will be a copy of this data in this HDF5 file. A rotated version of this cube will also be generated and stored in this HDF file. This is to be used to generate, for example, region spectral profile, so that the reading time from the storage will be minimal, and you can quickly compute the region spectral profile. And also the HDF file contains the cube histogram, or the histogram per channel, the statistics per channel, and also per channel there's a pre-calculated tile data, or the min map data. So if you so in this example we have image as a size of 32,000 roughly, and in this demo I just load this image in a fits format, and it will take like few seconds. This is with my laptop. Few seconds to load the image. However, if you convert this file into the HDF5 format and you just load it into CARTA, you will just like instant load, because the tiles have are calculated already. We just fetch the required tiles for the front end for rendering. Also, the histogram is also calculated, so just string this data to the front end for rendering. So this results in a very pleasant user experience with a minimal latency, and at the expense of more storage space. But if you have a large cube, you should consider to use this tool to convert the fits into HDF5 and use CARTA to visualize it for much better user experience. To conclude the overview of CARTA, I just provide some basic CARTA info. So the most important one would be the homepage, the cartavis.org. You should be able to find additional information from it. And this is just a screenshot when you load this homepage. We have an online user manual hosted with a ReaderDoc service. And also, if you want to deploy CARTA using the site deployment mode, please check this user manual, the CARTA controller, also hosted on the ReaderDoc service. If you have questions or suggestions, or just want to have a chat, please send us an email at support@carta-freshtext.com. And if you are interested in how the code base, and probably you want to contribute to our project, please check the GitHub page. Okay, so that's about the overview of CARTA. And the next one, I will start the tutorial for the first part regarding image loading and rendering. In this set of tutorial, I have a set of movies pre-recorded just to save time. So what you need to do is just to pay attention to the demo, and if you want to try it, and after this tutorial we have some time, and you can try and ask me questions if you have any. So the first one would be the image loading. Once you have CARTA launched, you should see the a screenshot or the graphical user interface like this one, there will be a file browser launched automatically with a set of images. And the first important thing is this green dot. So this green circle indicates the server-side status. If it's green, then everything should be good. But if it becomes red, then something went wrong. Okay, and in the file browser in CARTA, we support 4 different image formats. That includes CARTA format, FACE format, mirror format, and also, as I mentioned before, the HTML5 format with the IDIS schema. So you can just select an image like the movie here, and the basic file information header will be displayed to the right side. And if you have a long list of files, you can just use the filter down here to search for your images. And there are 3 different kinds of search modes. The default is fuzzy search. If you are more comfortable with the Unix pattern or even regular expression, then you can switch to that mode and just use the syntax to search for your image. So this is a basic thing to identify or locate your image in interest. And after you identify image, then it's easy to load it into CARTA. For example, you can just select one and hit the load button, it will just load. Or you can just double click an image to load it. And if you have one image already loaded in CARTA and use the file menu and also the file browser to load another image, then the loaded image will be closed first. So in this case, you only see one image in CARTA. But if you want to append another image, then you should use the append image menu, then launch the file browser to append your image. Then there will be 2 images loaded in CARTA. But what about if you have a set of images that you want to load? Then what you can do actually is to multi-select them and just load them in one shot. Okay, so this is the few simple ways to load a single image or multiple images. CARTA also support the 4D image cube that the fourth dimension is the Stokes axis. So in this demo, I just load a 4D cube, including the IQUV Stokes in CARTA. And once it's loaded, you can use the animator and switch over different Stokes values. And you can use the Stokes analysis widget to visualize them. However, usually, well, we may generate the different Stokes as independent files. What you can do is multi-select them and use the dialog to double check which is I, which is Q, and U, and V, and load it as a hypercube, which means CARTA combines the four images into one. So basically what you see is just a single image rather than 4 images. And you can still switch to different Stokes and also use the Stokes analysis widget to visualize this hypercube. So this will be a very useful if you work with polarization data. There are some other methods to load the image. For example, you can use the command line. If you use the package manager to install CARTA, then what you need to do is open a terminal and just type CARTA followed by an image. And basically, it will just launch the browser automatically and load this image automatically. And the trick of this one is actually using the URL query parameter and file. So if you want to automate your workflow, you can actually just append this string with an absolute path of your image to the CARTA URL and just load it. Okay, so these are the few ways to load images into CARTA. And the next one, we will be talking about how you can render your image properly. And the first topic will be the default, the raster image. One thing to mention here is the raster image rendering is accelerated by your local GPU. So this is why we ask you not to use VNC to use CARTA, because you won't be able to use the power from your local GPU to render your image. To get your raster image rendered properly, you can just use the render configuration widget. There are a set of clip buttons, and this histogram is interactive, so you can just drag or redefine the maximum or minimum the clip level. You can also use the dropdown to apply different scaling function. You can change it to different color map. You can use this 2D widget to control the bias and contrast interactively. And one special thing in CARTA is this color bar is an interactive one. If you hover over, and it will apply a cutoff to ignore the values below this threshold. So that those are just will turn into black and white. And this would be sometimes useful to investigate the structure of your source. The next would be, now we know how to render a raster image like this one. Then what if we want to generate contours based on the image data and overplot it on your image? In CARTA, contour vertex are calculated in parallel, so it should be quite fast. And also the contour data are rendered by the GPU acceleration techniques as well, using your local GPU. So to generate contours on top of the image, you just use the contour configuration dialog here. And in this label type, you can define a set of labels using the tools here. You can also actually click a value or redefine the value directly on the histogram here. Once you are happy, you just click apply. Then you should see contours being calculated and rendered quickly. If you want to change the styling, you can use the styling tab and, for example, make it thicker and change it to another color. And in CARTA, actually, we support the color map contours. So if you switch to line mode, and you can select a color map, and you will have a colorful contour images. Before calculating the contour vertex, we apply the Gaussian smooth to make the contour more smoother. If you don't like the Gaussian smooth, you can switch to the block smooth or even switch off this pre-smooth process. Okay, but again, by default, I think the Gaussian smoothing is quite fast, so you should consider use that as a default to make a beautiful rendering of your contour images. In CARTA, especially in the image viewer, we support a single panel or multi-panel view for now. By default, it's in the dynamic multi-panel view mode, which means it will the grid or the layout will change automatically based on how many images are loaded into CARTA. In this example, I'm trying to load 6 images into CARTA with one shot. And since it's 2 by 2 by default, so you should see 4 panels, then switch to another page for another 2 images. You can use the switch buttons down up here to change to single or multi-panel view, and also change to different pages. And if you switch back to the multi-panel view, actually you can maximize this viewer widget to have a maximum view. And you can use the settings dialog to change the grid layout. For example, in this case, 3 by 2 or 2 rows by 3 columns, and using the max area to view these 6 different images. Okay, and a common use case would be, say I have two images. They may come from different telescopes, or they are from the same telescope, but probably with different sky coverage or different array configuration, for example. And you want to compare these two images at the same time. So what you need to do is you load it into CARTA. And for example, in this one, I have two images loaded into CARTA. They are from Herschel, by the way. And in the side-by-side view, you can see they cover different part of sky. They have different coordinate system. What you need to do is using the image list widget and the matching buttons here to trigger the image matching. For spatial matching is X and Y. For spectral matching is Z, and rendering curve is R. And down here, you see some the box here. That means this image serves as the reference. And if you want to change your reference, you can use the context menu, right click to reset the reference. Okay, and let's try it again. So two images loaded. They have different sky coverage. They have different reference frame. One is equatorial, I believe the other is galactic. You just click X and Y. Then the secondary image will be matched to the reference image. And you can use right click and reset a spatial reference. Now the second image is the reference, and the first image will be matched to the second image. So this is the first, and this is the second. So this is the second. Now the reference, and this is the first image matched to this one. Okay. And how matching works in CARTA. So when we match images, the spectral matching is actually achieved by taking the world coordinate at the center of the image viewer. In this case, this is my reference image, and the center world coordinate is 10 hours and minus 30 degrees. And CARTA will use this coordinate and compute the amount of translation of the secondary image, the amount of rotation of this image, and also the scaling of this image, so that the world coordinate can be matched. So let's see how it may happen. So when I use the match button, you will see the secondary image is rotated, rescaled, and translate. And if you pay attention to the center part, you will see this source is matched. But if you recenter this source to the center, you will see this image is matched. That's because we take the center world coordinate to perform matching. And so please keep in mind that we don't change your projection of your input image. We keep as it is. We just change the amount of translation, rotation, and scaling of your image, so that at the viewer center, the image is matched. So if you work with wide field images with significant distortion difference, then please be careful when you compare your image. You may see the distortion, or say the difference, like this one. Okay. For spectral matching, it is performed by taking the spectral axis of the reference image in radial velocity. This is default, but you can configure it as a frequency or different convention. And then the secondary images are matched to fit the reference with the nearest interpolation. So a common exercise will be overplotting contours on top of other raster images. So in this case, I have two images with different sky frame and also different sky coverages. What you need to do is we generate a set of contours first. So I'm generating the contours for the reference image here and make it red. And on the secondary image, before matching, I can also generate another set of contours and make it green and thicker. Now what you need to do, so before matching, you can easily pan or zoom your image independently. But after matching, you will see that the contours are propagated to the reference image and to the secondary image. So this red contour is from the reference image, and these green contours are from the secondary image. If you just unmatch them, then everything will back to the state before matching. And there's a trick here. You can use the layers control button to hide temporarily the raster image or the contour image. Okay, so basically what you need to do is to use the matching function in CARTA to overplot contours from different images. Okay, this is the end of the first tutorial regarding image loading, rendering, and matching. And the second part, we will focus on some tools for spectral line analysis. The first topic will be the region of interest and the shared regions. So when we have a set of images matched, and a union list of regions will be created and serve as the shared regions among matched images. So what does this mean? In this example, before matching, I have two images. And on this one, I create two regions. On the secondary image, I create another two images. So in the region list widget, you will see, okay, this image have two, and this image has another two regions. After matching, you will see the region list contains 4 regions shared among these two images regarding which one is selected. But if you unmatch them, this secondary image will get a copy of the match, the union region set. And if you rematch, then again, you will see, because we are taking the union, so in total, we will have 5 regions. And in CARTA, we take the projection effect of regions into account. So for example, here I have an ellipse, but on the secondary image, you will see this ellipse is distorted. This is to ensure that same part of sky is covered, so that if you derive the statistics of within this ellipse, then you can directly compare the result directly. Okay, so this is so-called the shared regions and also the region distortion in CARTA. So mostly you won't see this effect if you work with small field images, but if you have a wide field image, then, or say the full sky image, then this will be quite significant. So now we know how to create regions. And a common exercise is to compare the spectral profiles from different image cubes. In this example, I load 3 CO cubes. This one is CO221, and this is 13 CO221 and C18O221. So I have then already matched together, and here you can see the nearest interpolation of the channel matching. And now I can create a region, and because they are matched, so the region is shared, and you can launch the spectral profile widget here. If you switch to a different image, then you will display the image directly for you. But if you want to compare them all together, you just check the checkbox here. And then in this case, 3 images are matched together, so you will see 3 profiles from the same area. And this spectral profiler not only can show profiles from different images. If you have one image but different regions, you can check the region check box here and select multiple regions to show multiple profiles. This idea applies to the same region, but you can generate requires different statistics. And this is also applied to polarization as well. Okay, so basically in the spectral profiler in CARTA, you can trigger multi-profile plot in different modes. You can generate multiple profiles from different images within the same region, the same statistics, the same polarization. Or if you have multiple regions on a certain image, you can generate multiple profiles from different regions from the same image with the same statistics and same polarization and so on. So I believe this is a powerful tool to compare different things, to view your data in different aspects. If you work with spectral line, especially weak spectral line, then CARTA can do profile smoothing for you to enhance the signal to noise ratio. And there are different modes built in CARTA, including the boxcar, Gaussian, Hanning, binning, sticky, Golay, and decimation. What you need to do is to use the smooth button here and trigger the settings dialog using the smoothing tab to select a smoothing mode. You can also trigger the overlay to compare the before and after smoothing. Okay, so this is the profile smoothing. By the way, there's a trick here. You see a cross here. That means if you press the F key, then on your image, then the cursor movement will be locked to that position. Okay. And if you have a profile identified and you want to know, for example, the integrate intensity, then let's say to know the velocity of a given line, then you can use the profile fitting function in CARTA to do so. There's a fitting button here, which pops up the fitting dialogues or the settings dialogues here, the fitting tab. In CARTA, we support Gaussian profile or Lorentzian profile. A special thing here is we have an auto detect function. So what you need to do is just click this button and it will guess the initial solution of your Gaussian components automatically. And you can hit the fit button to do so. If you're just interested in a certain feature, you just zoom in to that part and guess again and use the fit button to see the result. You can also use your cursor to define the initial solution of your center amplitude and forward sum maximum. You can also lock a given parameter for the fitting. Okay, so basically, CARTA has a special function called auto detect that can help you actually analyze your spectrum and guess how many components you can be fitted into to your spectrum, and also set up the initial guess center amplitude and forward sum maximum for you. But if you like the manual process, you can just use the text box here. Okay. You may also want to generate moment images to study the structures of for a given spectral line. So in this case, again, just use the moment buttons here from the spectral profiler widget, and it will pop out the settings dialog, the moments tabs. You can select a region. For example, if you just want to generate the moment images within this region, you just select that region. And you can use your cursor to define a spectral range. You can also apply a mask when calculating the moments. Then use the moments menus here to select which moments you want. In this case, we generated 0, first, and second moments of your image. And those images are once they are calculated, they are appended to CARTA automatically. So you will see additional 3 images appended to your to the image viewer. Then you can use the matching button here to match them and analyze them. And if you are happy with the moment images here, you can use the file menu and use the save image menu to save a given moment image or images. You can with the version 3 beta 2 version, you can generate PV image. And the good news here is the performance compared to CASA or CASA viewer is significantly improved due to a different approach on how we generate PV images. To generate PV images, the first thing is to define the PV code using the line region here. And you can call out the PV generator widget. Just hit the generate button. Then once it's generated, it will, like moment images, the PV image will be appended to the image viewer. Then if you are happy with this PV image, you can also use the file and the save image menu to save the image. Another important thing here is the PV generator in CARTA support the wide field image. That is, for example, I have a fake, or say just for demo purpose, a set of Gaussians. They are all the same with the same size, but placed at different places on the sky. But after sky projection, you will see a set of Gaussians like this. So near the edge of this celestial sphere, you will see the Gaussian is distorted. That's due to the projection effect. And also the separation between each Gaussians are different. This is again due to projection effect. However, when you make a cut and request the PV image from it, CARTA will actually calculate the offset with equal angular separation. That is, on your PV image, the offset axis is linear. And in this case, you will see the stripes with equal distance instead of a variable distance. Okay, so this is just to take the projection effect into account. So if you, in the near future, you work with full sky image or wide field image, so keep this in mind that we take projection into account. So since ALMA is basically a line imaging machine, and often because of the super sensitivity ALMA can have, you will see a lot of unexpected molecular lines from your source, especially from galactic source, star forming region, or even nearby galaxies. So CARTA supports the spectral, a tool called the Spectral Library widget that allows you to search for lines from the Sparlog service. So in this demo, I loaded 2 spectral windows into CARTA. They cover different frequency range, have them matched, and you trigger the multi-profile plot. Now I switch back to the frequency axis. So you see there are 2 parts of the spectrum taken from different spectral window. So what you need to do is you can use the Spectral Library widget here, type in a range of frequencies and set the intensity limit for the lines, X for a set of spectral lines from Sparlog. And once it's done, it's displayed as a table. And here we can see there are over 66,000 lines. You can use the filters here to search for a certain line, in this case, meso format. Then I set a proper Doppler shift. Then I can overplot these line labels directly on your spectrum. And here you can see, there are a set of meso format lines in my source. Okay. The last part of the spectral line analysis tool is often, so once you identified a set of lines, for example, in this case, I have a NH2CHO line here and 4 CH3CN lines here. And what if I want to compare the features of measures of the methylcyanide K equals to 3 to NH2CHO? In this case, I have the same cube loaded twice into CARTA and have then matched together, and I trigger the multi-profile plot. And because it's actually the same image cube, so you will see just one profile here. However, what you can do is use the settings dialog, and you can apply a new reference rest frequency per image. For example, I type in the frequency for NH2CHO. Oh, this one should be the methylcyanide K equals to 3. And this is the NH2CHO. And once you have done that, you can switch the frequency label to radial velocity. And now you can see the two target lines are matched together in the velocity frame. And also you can compare, for example, the images from this channel and this channel. Okay, sorry, just a mistake click. Here. So you can once they are matched using the nearest interpolation, then you can compare the emission features side by side, for example, in this case. Okay, that's the end of the spectral line analysis tools. And the third one would be working with catalogs. So for catalogs visualization, what you can do with CARTA now is if you have a local catalog file in VO table format or in the FITS format, that can be loaded into CARTA for visualization. Another thing what you can do now with CARTA is there's a remote catalog query here, and you can use that dialog to request to fetch the catalog from Sinbad or Vizier. So let's see how we can do it. You can use the import catalog menu, select your catalog. You can see the metadata here and load it into CARTA. So once it's loaded, the catalog widget will be launched, and you can identify the RA column and the DEC column and visualize them as an image overlay here. Alternatively, you can use the online catalog query. Say I'm trying to request a catalog from Sinbad within this sky area. So once it's loaded, there will be two catalogs. One is the original one from the local, and the second one from the remote. You can also select the right engine declination for visualization. And just for demonstration purpose, I changed the color of the catalog retrieved from Sinbad. So you see this green part is from Sinbad, and the cyan color is the local one. Okay. So once a catalog is loaded in CARTA, it's displayed as a table in the catalog widget. So in the upper part, you can see the column definition here. You can also use the toggle to hide or to enable or disable a column. And you can identify which is RAS engine, which is declination for visualization. You can apply a filter, say I just want the angular distance between 50 and 100. So now you will see only around 600 sources within this range. And we can also search for, say, supernova or supernova redundant within this range. Then there will be only 6 sources within this range. So basically, what you can do with this widget is to visualize the catalog as a table. You can enable or disable a certain column. You can use the filters, or say the sub-filters per column, to search for your sources. Once you filter your catalog, you can visualize them as a as an image overlay. So not only you can visualize your catalog as an image overlay, the CARTA also supports another two modes for rendering. So this is the image overlay that you already know. You can also, for a given column, you can also calculate the histogram. So I'm just plotting the histogram of my right ascension column. You can also say identify two columns and visualize them as scatter plot. In this case, the angular distance versus declination. Okay, and it's worth mentioning that the image overlay here is also rendered with GPU acceleration techniques with your local GPU. That means if you have millions or 10 millions more sources, they can be rendered quickly while retaining good responsiveness for the user interface. So if you have your catalog rendered as an image overlay, as a table, histogram, and also scatter plots, there's a feature called the linked catalog visualization. You can use the select button here to select a given source. Once that source is selected, all the other plots or table will be highlighted with the selection. For example, I'm just selecting sources directly from the table, and you will see that the relevant histogram bin will be highlighted on the scatter plots highlighted, and also on your image. And for example, I can just select a certain histogram bin. Then the data within that bin will be highlighted on the image, on the scatter plot, and also on your table. So this is so-called the linked catalog visualization. The final part regarding the catalog visualization is so-called the marker-based catalog rendering. So by default, we just render your source with the same marker, and also that's the same size and also same color. But what you can do actually with CARTA is you can identify a given column and map the value to the markers, say size, color, or even orientation. So here I just demo how to change the appearance for the usual marker. But you can use the menu here to map a certain column, say angular distance, so that you can have variable marker size based on the angular distance. So you see smaller here and large here. You can also map the color, say again with angular distance, with different color. And you can say switch to a different marker type like a line segment. You can also map a given column so that it's treated as a different orientation of your marker. Okay, so this provides a good way to visualize your catalog efficiently. You may be able to find out a hidden signature within this massive catalog table. Okay, and the last part would be the GUI customization. So basically, CARTA supports a very flexible layouts. You can easily configure your layouts with your mouse. You can resize it easily. You can say close some and create another one. So in this case, I'm trying to make a spectral query widget here, and another spectral profile widget down here. This is just for say I would like to identify my lines. So you can save this layout and just give it a name, say line ID. You can save it. And you can use the menu here to switch to different predefined or your saved layouts quickly. Say I just switch to my default and also switch back to the line ID. And if you really want this custom layout to be your own default next time you use CARTA, you can use the preference menu and just set that line ID layout as your own default. So next time we restart CARTA on the next day, load another, say, image cube, you will see the exact layout you saved as your own default. So you will save some time for you. You can also actually use this function to define several layouts for different purposes. For example, one for our continuous analysis, the other for spectral line, etc., etc. So in CARTA, there are actually a lot of configurable. For example, in this case, the default color map is Inferno, but I don't like it. And by default, the region correction mode is center to corner. I don't like it. And I don't like the light thing. So what you can do is use the preference and change to the dark mode as your own default and change the default color map to, say, jet. And you can use the region and change the correction mode to, say, corner to corner. That's probably more intuitive to me. Then the next time when you launch CARTA, see, this is the dark mode. And you load the image. And the default color map now is jet. And if you generate a region, then it's corner to corner correction mode. Okay, and there are actually a lot more that you can configure. So please try to explore the preference dialog. All right, so basically I quickly go through different topics about CARTA. And this is just a summary of what we have achieved today. So you should know a little more about CARTA. You should know how to load images into CARTA in different ways, how to render raster images and contour images, how to match them, and how to overplot contours on top of your raster images. You should be able to know how to use spectral analysis tools like PV generator, moment generator, spectral line ID, multi-line plot, Gaussian fitting, profile fitting, profile smoothing, etc. And you should also know how to customize your graphical user interface, like the screenshot on the right-hand side. All right, so this is my last slide. I would like to thank you again to joining this tutorial. And we really hope that CARTA can make your life easier. To know more about CARTA, we encourage you to visit our homepage, cartabiz.org. Thank you for listening.